Hello friends, Standard 12 Chemistry, Unit 10, Haloalkanes and Haloarenes, Part 9. Last time we discussed about chiral atom. So this is the structure of glucose and fructose. Glucose has 4 chiral carbon atom, while fructose has 3 chiral carbon atom. And last time we discussed about plate polarized light. If plate polarized light is rotated to the right side, it is said to be as dextrorotatory. Suppose it rotates to left hand side, so it is said to be as levorotatory. Dextrorotatory, it is indicated by plus sign, or levorotatory, it is indicated by negative sign, or small letter L and D. Okay, so how can you identify either it is said to be dextrorotatory or levorotatory? Simple, always check last hydroxyl group in this particularly glucose or fructose structure. Suppose hydroxyl group, last OH group, is at the left hand side, right hand side, it is said to be as D-glucose, dextrorotatory glucose. Okay, so it is said to be also D-fructose. Okay, this is the simple phenomena. Sometimes you will be asked in examination. Okay, suppose this hydroxyl group is at the left hand side, so it is said to be as L, means levorotatory fructose, L fructose. Okay, the, or it is signed to be as this D or plus fructose, or here D or plus, okay, glucose. So one thing is, remember, so please only check here last hydroxyl group, OH group. Okay, let's see another example. Here 2,3-dihydroxy butane dioic acid. Here dioic acid, that means here 2 times of COOH group, butane dihydroxy, so this carbon is considered. Then after, on second position OH group is added, on third position also OH group, and then COOH. Okay, this is the structure of 2,3-dihydroxy butane dioic acid. Its general name, that is tartaric acid. So how many chiral carbons are present in this molecule? First and last carbon is not said to be as chiral carbon. Let's have a check this. Here let's see COOH, another. Let's simplify this structure also. OH, and then after COOH. Okay, so here in this case this carbon is attached with 4 different atoms or groups, so it is said to be chiral carbon. Same condition is here, chiral carbon. Okay, now let's see its mirror image. One thing is, remember that in mirror image, only the position of the right hand side or left hand side, left hand side or right hand side is changed. Top or bottom of the groups will be not changed. So simple. Here COOH remains as it is, but here the position of hydroxyl group is left hand side and here hydrogen on right hand side. Here same condition, hydrogen is shift to, and okay, same condition. So this is the mirror image of tartaric acid. So it is said to be as, here only check last hydroxyl group on right hand side, so it is said to be as levo rotatory and it is indicated by negative sign. Here OH is on right hand side, so it is said to be plus tartaric acid. Okay, now it is said to be as optically active. Why? Because of their mirror image, and it is not, this structure is not superimposed to this structure. Let's have a look at this. Here suppose it's mirror image to superimpose here, so this this OH is not superimposed to this because it's a OH and it's hydrox H atom, so it is not superimposed. And non-superimposable mirror image that forms a chiral molecule are called enantiomer. It is said to be enantiomer. Okay, have a look at this. Non-superimposable mirror image, non-superimposable mirror image forms of chiral molecule. Why it is said to be as chiral molecule? Because this structure has two chiral carbon atoms, so it is said to be chiral molecule, but it is not superimposable, so it is said to be molecule are called enantiomers. Okay, let's have a check this. Here the upper part, suppose here we divided into two part, this structure is divided into two part, so upper part of the molecule and lower part of the molecule becomes equal. Have a check this. This is the lower part of the molecule and this is the upper part of the molecule, so it is to be equal, so it is said to be as mesoform. It's a mesoform. Okay, so it is said to be as internal mirror image. It is said to be as internal mirror image. So enantiomer and mesoform. Here for enantiomer, non superimposable mirror image, and mesoform, that means upper part or lower part, upper part and lower part of the molecule become equal, that means its internal mirror image, and it is said to be as mesoform. And this mesoform is optically inactive. Okay, so this is the here OH plus or minus here meso compound. So here we can write for meso compound upper part and lower part. Here this is for your only understanding of molecule become equal. That means its internal mirror image, and it is said to be as optically inactive. Why it is said to be as optically inactive? Because here the optical rotations of one asymmetric carbon atom, suppose it is rotated to the right direction, or suppose it is rotated to the left direction, that means it is cancel out by that of the each other. So it is said to be as optically inactive. Here I will repeat, optical rotation of one asymmetric carbon atom is cancelled by that of the other. So it is said to be as optically inactive. Here the dextrorotatory tartaric acid and levorotatory tartaric acid that that does not rotate the plane of polarized light. So it is said to be plus or minus tartaric acid that does not rotate plane of polarized light. So that's why it is said to be as optically inactive. It is also meso compound, that is optically inactive, and it is form equimolar mixture. This forms equimolar, that means equal amount of two isomers, equal amount of isomers, or two isomer, that means equimolar. It forms equimolar mixture of, is for your understanding, equimolar mixture of dextro and levo forms, and this is said to be as racemic mixture. It is said to be as racemic mixture. So here enantiomers, then after racemic mixture, and then after meso compound. These all are interrelated with each other. So suppose, what is racemic mixture? Here equal proportion of dextrorotatory and levorotatory is called racemic mixture. It is called racemic mixture, or another word we can say mixture of equal amount of two enantiomer. Mixture of equal amount of two enantiomer is called racemic mixture. So this racemic mixture is said to be as optically inactive because two components rotates the plane of polarized light equally in opposite direction, that cancel out with one another. So it is said to be as optically inactive. Okay, so this chiral molecule, then after enantiomers, then after racemic mixture and meso compound. Okay. Okay friends, next time we will discuss another examples of meso compound. Thank you very much.